In this lesson we're going to look at relative atomic mass. Now you might also like to refer to the lesson on isotopes in the unit on atoms and elements. Anyway, the symbol for the relative atomic mass of an element is this. It is AR, okay? Notice it's got a little r here, whereas the symbol for the mass number or the nucleon number is just the single A. Okay, and you can find the relative atomic mass on the periodic table. We've got a snippet of the periodic table here. Okay, and we're just going to take, for example, a look at the element copper. And you can see, as on all of the elements, there are normally two numbers are given, and the top number refers to the atomic number, that's the symbol Z, and the lower number refers to the relative atomic mass of the element, that's the symbol AR. So what is the relative atomic mass? Well, it's the mass of an atom of an element compared with that of carbon-12. Hence we use the term relative. Now you'll notice that on the periodic table here we've got 63.546, then 65.39, then 69.723. You'll notice that these relative atomic masses are very, very rarely whole numbers, and the reason for that is that they are in fact the average of the mass of the isotopes of each element. So for example, if we take the case of copper, well, copper has got two isotopes. It's copper 63 and copper 65. Remember again that the top number is the atomic mass number, which is also known as the nucleon number, which is the symbol A. Notice not AR. And the lower number is the atomic number, which is given the symbol Z, which is the number of protons in the nucleus. The atomic mass number is the number of protons plus neutrons in the nucleus. Whereas in isotopes the proton number is always the same. That's to say the atom has the same chemical properties. The atomic mass number can be different. It can have a different number of neutrons. So these are the two stable isotopes of copper, and they have different abundances. Now the abundance of copper 63 is approximately 69%, and the abundance of copper 65 is approximately 31%. So if you take a piece of copper tubing used for plumbing, for example, 69% of the atoms of copper in that tubing will be this type of isotope and 31% will be this type. So when we calculate the relative atomic mass of copper, we need to take the average atomic mass of these two isotopes. So let's say we have a sample of 100 atoms of copper which exactly reflect these proportions. To calculate the average, you would take 63 multiplied by 69. 69 of the atoms will have an atomic mass number of 63, while 31 of the atoms will have an atomic mass number of 65. To get the average, we divide that by the total number of atoms, which was 100, and that will give us 63.546, which is the value that is quoted on the periodic table. So just to finish, what we can say is that although this is not actually a mass, it's a relative number, we can say that if we take 1 mole of copper atoms, and we'll look at the mole in the next couple of lessons, and you'll understand this statement a lot better when you've looked at that lesson, but if we take 1 mole of copper atoms, then the mass of a mole of copper atoms will be 63.546 grams.